Okay, hi guys. So in this lecture, we'll be talking about starting off with the um, alkyl halides. So just putting the heading alkyl halides. Okay. So before starting off, we need to have a check on some of the important concepts, which is first solvent. So solvent, we can have two types of solvent. One is non-polar. Non-polar means whose mu is 0. Mu is dipole moment. It can be means I'm just listing some of the examples, but there can be many. Examples are n-hexane, then we have CCl4, we have benzene. Okay, then we have polar solvents whose mu is not equal to 0, and they can further then be classified into two categories or two subcategories. It is known as polar protic and polar aprotic. So in polar protic, it means we have H attached to any of the fluorine, oxygen or nitrogen groups. Examples can be, there are many: H2O, HF, or NH2. Okay, then we have RCO2H, then we have NH3, just like this. And polar protic are not of the form that H is attached to any FON, they are directly attached to carbon atoms only. So we have acetone, this is called acetone. Then we have aldehyde. Okay, so this is all about the solvents and the types of solvents. Okay, now let us talk about one important solvent, which is called DMSO. DMSO is nothing but dimethyl sulfoxide. And dimethyl sulfoxide, the structure is okay. We have something known as DMF. DMF is nothing but dimethyl formamide. And it is nothing but this dimethyl formamide. Okay, now we'll talk about something about crown ether. Crown ether is something like this. We have so here X is the number of crown, where X is equals to 18, and Y is the number of ether, or this is the representation of this compound X crown and Y ether. Here in this specific example, X is 18 and Y is 6. So by X we mean number of carbon, and so if you count the total number of carbons, 1 2 3 4 5 6 7 8 9 10 11 12, and 6 are the oxygen. So X is the number of carbon plus oxygen atoms, and Y is the number of oxygen atoms. Okay, similarly we have this structure, and we have another example is we can have X here as 12. X is the crown, number of crowns, and Y is for ether groups, ether or oxygen atoms. Okay, so basically crown ether is used to trap cation in any of the solution, any of the equation or reaction. Similarly, DMSO is also used. So DMSO and crown ethers are used to trap cations in a reaction. Okay, so let's say we have Na plus is the cation, here here here. So this is the DMSO, and similarly for crown ether you can make it, not a big deal. Okay, then we have what is a host guest relationship in a crown ether. So crown ether has a host guest relationship wherein host is obviously the crown ether and guest is cation. Okay, so as cation is surrounded by the host. Why? As cation is surrounded by the host. Okay, example DMSO or crown ether, etc. Okay, so at the last of this lecture, let me end this lecture with some reaction. This is some reaction in which if we react this alkyl halide with KCN, we will get A compound, and if we react with AgCN, we will get B compound. So A is nitrile group and B is isonitrile group. Just remember this, we will discuss it sometime later in our lecture series. Okay, so with this we come to the end of this lecture. I hope you enjoyed it. So good luck and goodbye till next time.